All right, it is 7 a.m. and we are meeting for the first time after Brisbane IETF 119. Note well, this meeting is recorded. Our main goal is to talk about, as soon as I can, yeah, our main goal is to go through the editing of the document, but let's see if we can briefly discuss the progress on RA flag document that we need to send to 6-man. Is that okay?
Yep, with me. Anyone else have preferences, thoughts?
That seems like a good idea. I'm trying to remember where we were with that, actually. I know we had a big discussion about something. It's like, oh, my whole cache is blown at this point.
I can try to give an update on it that'll hopefully shake some cobwebs out of people's heads, and move on. This is the RA flag draft to 6-man. I believe is our first topic, and the last status of it was that the authors had uploaded an updated version after the previous IETF meeting, and it is waiting for the authors or SNAC. We can go either way, but usually the authors to ask 6-man for adoption, which I imagine will happen pretty simply and quickly, and the draft can move along through 6-man.
Why don't you guys just ask the chairs in 6-man to do that? I think you know, because you're sending.
Yeah, the email just has to go to the list, and we've got a draft author editor
Okay.
who can do that. So we've talked to the chairs about it. Chairs say yes, please send it to the list and ask for adoption. That way the working group gets to chime in, because it won't just be the chairs that say yes, we'll adopt it, right?
But they would put it up for adoption. Yep. Yeah,
absolutely. So that is our first thing. So Jonathan or Ted, Jonathan is not here. If there are no objections, and speaking as a chair, since Tim had asked this, does anyone have an objection to myself or Kieran simply doing that on behalf of the Stub Router RA flag authors?
Darren, Jonathan is on.
Jonathan is here. Hey, Jonathan.
Yay.
Hello.
Hi.
Okay, we were just talking about draft Stub Router RA flag 02, and that it is ready for ready to ask 6-man for adoption, and it would be great if you could fire off an email to ask 6-man to adopt it. Okay.
So we're good with the draft as is. I know there was some discussion around the placement of the bit and whatnot, but
so I thought the place where the discussion landed was that we were going to let 6-man decide whether it would be an extension bit or not.
Okay.
And I thought we did a working group sort of last call on whether we were good with the document as is, and that finished.
Good.
Is that right?
That is correct.
And I think there were no action items taken from that.
Also correct.
Okay, so yeah, I think that means that we can just ask 6-man for adoption, and I would suggest also that we ask 6-man for early allocation, because it always takes a certain amount of time to go through the process, but it would be nice to have a bit.
For sure.
Yeah.
Okay, so allocation request will also go from 6-man then.
Correct. Yeah. Just a note on the allocation request: they will. They won't make the request until it is adopted, because the draft has to be adopted to get the early allocation. But that's okay if you ask them for both, and they'll queue it up appropriately.
Okay.
And we can always remind them if it doesn't happen.
Correct.
Okay.
Jonathan, would you try to send that today itself to get the ball rolling?
I can do that. So I just email the chairs?
No, email the working group.
Email the.
Yeah.
Okay, so just send email to the 6-man group.
Yeah, because
That's
call
right.
for adoption is actually a request to the working group. The chairs just moderate it. They're not in charge of deciding.
Okay, yeah, makes sense.
Okay, so that is out of the way, and we can get to document issue handling. At this point, Ted, are you ready to share GitHub and start scribbling or scribing, or do you want someone else to share the screen?
Okay, so we have I think there are two tasks here. One is sharing the screen and one is taking notes. I don't think we can do both on this. The same person can do both. So I have the GitHub repo in my other window, so I can share that if that makes sense.
Yeah, let's do that.
And as a working group participant, I'll just a little agenda bashing. Tim had asked, or maybe it was Tim, maybe it was someone else had asked about ordering of items. So if we could maybe quickly go through a ordering of items of issues.
But Ted probably has an order in his head, basically.
You may, yeah.
I wouldn't jump to any such conclusion.
No.
But we at least have a list, and it's not long, so I don't think we have a big problem.
Yep.
Okay.
So
Then my proposal is simply that we pick the top 2 or 3 and.
Yeah. Well, we actually have a pull request, which is probably worth discussing because that's like, once we approve it, then we can go with it. And I think it's ESCO's pull request. So is that right? Oh no, it's me actually. Okay. Well, anyway, so I asked for screen sharing. Oh, am I sharing?
Not yet. I see an ask here. I think. Click on the right button. And yes, grant screen. There you go, Ted. We did not click on who would be taking notes. So if we have any volunteers, that's great. Otherwise, I don't mind taking them.
I can help.
Was that Tim?
Yeah, I can. No, that was Jonathan. I can also help. I've got the HedgeDoc thingy up, so.
Okay.
Yeah, where's the link to that?
It's at the top of your window.
Oh, got it. Yep.
Got
it. Thanks.
Taking tool.
So are you guys seeing my screen?
Could you zoom it a bit?
I can. Not easy. Well, let's see. Yeah. Okay. I guess the answer is yes.
Yeah.
Is that any better?
It's better.
Yep. Fine.
Okay. All right. So I think the idea with this pull request was going to be to add an appendix that described the topology stuff, which I think this does. This also seems to have some other changes in it, though. It's actually okay. So here's the appendix, I think. Yeah. So we had a bit of discussion about this. Unfortunately, as I said, my cache is blown. Somebody was raising an issue about whether we were actually sufficiently discussing sort of somebody's talking about the sort of the rogue RA thing, and I'm trying to remember the details of that conversation. Let me see.
Yeah, I can maybe also explain a bit. I think I created the
Oh,
issue
okay,
that led
go ahead.
to the pull request. So
Yeah.
yeah, there was an email list discussion about, okay, what if you have a sort of setup of a network that is okay in the IETF sense, and then you bring in a SNAC stub router, and then it will basically mess up that configuration. Like out of the box, it will interfere with the intended configuration. And it was stated on the mailing list discussion, at least, that something that we well, don't want to have or want to avoid as much as possible. And then the question came up like, okay, in what specific network configurations will a SNAC stub router work okay, and in what will it not work, which is also okay if it's not intended to work there. And in the third case was what configurations will the stub router basically mess up the network, so it starts misbehaving. I think what we wanted to do is make an appendix which shows all the possible deployments we can think of, kind of categories, and then show for each one of them, well, either it works out of the box or it does not work, but it's okay because it's not targeting that use case. And the third one is it does mess up the network, but well, maybe that configuration was not a good one. I think that was what we wanted to show. So we found at least one configuration that is going to be messed up, but it's also not, in our objective definition, it's also not a good or not an optimal network configuration.
Yep.
So I think the idea was to describe all of them, including the good ones and the bad ones.
Yeah. So I think the pull request. So I'm trying to figure out where this pull request is on some branch, presumably. So, and that's, I guess this is the name of the branch. So
Yeah, 52 topology taxonomy.
yeah, okay. So the reason I did that is because I think it's actually very difficult to look at this in the yeah, here we go. It's difficult to look at it in
XML.
in XML. Well, it's difficult. It's basically just difficult to look at it in the diff.
Yeah.
Is this readable, or should I make this bigger? Are you guys seeing this okay?
I can read it fine.
Okay. Okay, so oh, right. Okay, so here's the appendix. So analysis of deployment scenarios in which stub router could cause problems. So the first is an unmanaged home network.
Ted, just a question here. Sorry,
Yeah.
Do we want to give? We want to take 5 minutes and say, everyone, read all the words here.
I would be okay with that if everybody else is. Yeah.
All right. Can we do that, folks?
Sure.
Okay.
Yeah.
So Ted, a question in terms of topology, can we say we support three cases: managed network, unmanaged network with IPv6, and then IPv4 based network? So I mean, I'm trying to see what is the simple one paragraph we can add in the introduction that says, okay, this is the kind of network where SNAC will work.
Right.
So can we speak words?
So so basically, you're saying add a paragraph here.
Yeah, I
No, I
wanted
think
something which is
in the
next
introduction
and can
itself, right? Sorry.
Ted, my preference is this should go outside appendix in the main document.
Okay.
Yeah, like
Well, I think,
in the introduction sort of thing.
yeah, but the first question is, what would the statement be? So is the statement, Ted, you were just starting writing it, stub routers can be deployed in any network, right? I think that's the statement.
Yeah. Right.
Yeah. Yeah. So, yeah,
That's
that would be a good statement to say in the introduction.
Does that make sense, or do we need to enumerate something here?
No, that looks good.
Yeah. And I think not even, I think you might want to say stub routers can be attached to any network, period.
Sure.
There are network configurations where stub router might not work. Yeah, that's fine.
I mean, we might as well say will not work, because it's not really, there are scenarios where indeed it will not work. So, all right. So, and then let's put this in the introduction somewhere, is the plan.
Yep. Kieran, does that satisfy you?
yeah, it's as I said, it's my preference, but if anybody disagrees, I can back off.
No, I think it's
Yeah, no, I think it's a reasonable ask. The introduction is quite long though, so not necessarily a bad thing, but just bear in mind. And we probably
What we
probably
would
could
do
put it
is,
in here actually.
and we will create subsections so that it is well ordered.
Yeah, right. So that's right. So I think this actually fits pretty nicely into the usability goals subsection, if that works for you, Kieran.
Yeah, that's fine.
Okay. All right. There we go.
Only concern here then would be, are we putting some technical information early on that has already been that will be described later, so it could get overwhelming for the reader who's going through introduction.
Well,
So like
so I would say we have an abstract that tells the reader whether they want to read the document, at least in principle. That's what the abstract is for. And so the abstract says that it describes a set of practices for connecting stub networks to infrastructure networks, and it's applicable, for example, and that's about all it says. So basically, that's giving you what you need to know if you want to read this. And then here, in the introduction, yeah, the introduction is quite detailed, but so this is motivating, right? This is why we want to do this. So that kind of belongs in an introduction. And then this is like, what is a stub network? Which kind of makes sense. And why do we implement transit? So again, this is just talking about motivation. You know, here's a configuration that could happen. We're not saying it can't. Here's what we're trying to
I've
do.
gone through. Yeah, it's fine to pull it up. I was earlier concerned if we are using some like timers or something that are described later in the document, but there's no such thing, so we are good.
Yeah. Yeah. Okay. Good. Yeah. So yeah, the whole point of this, I mean, it is. There's a lot to say in the introduction because it's really trying to get across the concept of what we're doing and why we're doing it this way and so on and so forth. So I think, yeah, I think it's good. Okay. So back to the appendix. We were doing a read of this. I don't remember. I don't know if everybody got through it. I also don't remember if that last section was fully visible.
So we can, I'll just pull up the pull request. I'll send it to, send it on the chat if anyone.
Now I've been making edits, so the pull request is going to have been, the pull request is going to change, but.
Yep.
Okay, so, and then there was, Esco actually had a comment, I think, about this, that it was a little bit, this sentence here, that it was a little bit unreadable. So I'm going to see if I can fix that while we're on this. So rather than the previous statement was, it's not implausible that it might, yeah, and it's like basically what I'm really saying there is this is a perfectly reasonable thing to try to do. So hopefully that's a little easier to read. Okay, so I can actually
I did have one question on use on a properly managed network. Do we have use on unproperly managed network?
So so we've got unmanaged network.
Yeah.
And so properly managed, I mean, what we could say here is that what it means for a network to be properly managed is blah, blah, blah. So, I mean, we kind of cover this. I mean, we could just say on a managed network and forget about properly.
That's what I was thinking.
Yeah.
Okay. Okay. Yeah. Because we actually cover like, okay, you know, the network has array guard and, you know, this is actually a useful
comment for it. And that would be, you don't have to track it.
I mean, there's an interesting, excuse me, there's an interesting question to consider here. Is it possible to detect that RA guard or port-based access control is present and maybe disable the stub network functionality or communicate to devices on the stub network that only NAT64 will work or something like that? I don't know if we need to do that, but you know, in principle,
Joe,
it's.
That would be something like best practices or operational practices type of things, right? That's not.
No, I mean we need a signal. If we so the question, I mean the question I'm asking is, do we need a signal? Like, is there a reason? Like, basically what's going to happen is you're going to plug your stub network into the infrastructure network and it's not going to work because RAs aren't being distributed, or we have port-based access control or whatever. So although NAT64 will work if IPv4 is working. So do we need to do something about this? Do we need to have a way to notice that this is happening and perhaps turn off the stub network functionality when this is happening or something like? We haven't considered that in the technical specification thus far. I don't have a strong opinion on this.
So if you need a signal, do you need a does that require change in the behavior of home router itself, or is it something that can be detected again using a state machine?
Well, so the thing is, I don't know that we can. The only way that we could actually discover that RA guard is present or that port-based access control is present in blocking router advertisements is either to have some other device that is looking for the RA and not seeing it and reports somehow back to the home router, or to have an RA option of some sort that says we're doing RA guard and so stub router is not going to work here. I don't think that RA guard specifies any way to signal that RA guard is present, so we would have to add that.
I think in that case.
Sorry, go ahead, Karen.
So my preference is in that case, it is just good enough to mention in the document when it will not work so that implementers know that things are not working for a certain reason. Because otherwise, I think we will need change on the other side also, home network, to be able to send this kind of signal, which is probably not what we were trying to do as part of the scope of this work.
Mm-hmm. Yeah, it feels like it might be useful to be able to send a signal like this, but yeah, as you say, it's somewhat out of scope of what we originally talked about. And I think if somebody goes like, I'm just trying to imagine like if I were to go say to work at Apple and plug a stub router into the Apple wired network, what would I expect to have happen? And the answer is, I don't think I would expect that to work. Now, I'm a fairly knowledgeable user, so I might not be the best example. But that's really the question. Is like, is there something we and I think the answer is there's not actually a way we can do anything about this, so maybe we should just say that.
Yeah, Ted, the stub router works. The network does not allow it to communicate, right? The network does not allow it to communicate with things on network because of RA guard.
Well, what would happen? What would happen is not that the stub router couldn't communicate with things on the network. Stub router is just a, excuse me, from the network's perspective, it's just an IP host, right?
Yes.
So, so the stub router isn't going to have a problem communicating with devices on the network. It's devices on the stub network that are going to have trouble communicating with devices on infrastructure.
Right, but that's
also
exactly the end of the infrastructure network by deploying RA, right?
Right.
So
there is one.
Exactly as it's supposed to.
Sorry.
It sounds to me as though it works exactly as it is supposed to work.
Yeah. The challenge that we have here is that we can advertise MDNS, and if the local network infrastructure supports MDNS, we're going to be advertising services that aren't reachable. So whether we care about that or not, I don't know. We should probably note it.
Yeah.
If MDNS works on the infrastructure link, the stub router will function correctly because the delegated prefix will be correctly routed. No, this is wrong. It's DHCPv6 PD that works, not MDNS. So I think I would say it might be worth adding a paragraph here that says when a stub router is attached to an infrastructure that has deployed RA guard and does not support DHCP v6 PD. I don't know what more we need to say about that, but I think that's a true statement that's worth making.
Yeah, absolutely. I agree.
Okay. All right. So I think we've covered the managed case at this point. Is that true?
I would say yes. Anyone
Okay.
else?
Yes.
Yeah. Okay. And then I think that this statement, I feel pretty good about this statement. A managed network without IPv6 is not expected to implement RA guard. And on such a network, a stub router, there's the parenthetical there. I'm not actually that sure about. Like maybe it should, maybe it shouldn't. But on such a network, a stub router will connect and advertise services, and it will work. So, so I think this is all true. I guess my one question is, should we say anything about, although it probably should? Because I mean, in principle, like, you know, if a device connects to, if suppose I have like an iPhone. I mean, this is not a real world scenario right now, but suppose I had an iPhone and I connected it to this IPv4 only managed infrastructure and turned on IPv6 tethering. There isn't any such feature on the iPhone right now, as far as I know. But if there were, then that would advertise a default IPv6 route on this managed network. Tethering is a little bit off topic for us. That's not really what we're talking about here. The reason I mention it is it's sort of illustrative. If we had a stub network, I mean, a stub network's never going to advertise a default route. I guess that's the thing to say. A properly behaved stub router will not advertise an IPv6 default route. Therefore, it should not cause operational problems, just as connecting an IPv4 net gateway wouldn't. So yeah. So I think this is okay. This is. I mean, I'm still uncomfortable with it. Probably should. I think it's not really our place to say that. So
I have
there we go.
another question about properly behaved stub router will not advertise default route. Is it possible for home router to catch it in any way?
To catch it.
So a system auto recovers.
A system does what?
I mean, like if I have a home network and for some reason a misbehaving stub router starts advertising IPv6 default routes, will my home router, that's the gateway, will catch it and the network will self-heal or come back to a
No.
normal state? It's not
No,
possible.
what's gonna if you well, so if you have, are we talking about a v6 only? Sorry, an IPv6 or dual stack network? Or are we talking about a v4 only network?
Pure IPv6.
Okay, so on an IPv6 network, if the home router is advertising a default route and a stub router comes and advertises a default route, that's going to cause significant operational problems because now it sort of depends. at this point, there's I don't know how much you guys have been following the IPv6 mostly work in 6-man and v6 ops, but there's a pretty strong push in the industry at this point to implement Rule 5.5 in the source and destination address selection algorithm, which historically hadn't been commonly implemented. And what Rule 5.5 says is when I have a prefix that's advertised by a host, sorry, by a router, so a PIO option advertised by a particular router, and I want to send a packet using an address on that prefix as the source address, I have to use the router that advertised that prefix. So as long as the stub router is not advertising a globally routable prefix in a PIO option, then even if it were advertising a default route, it would never get selected as a default router by devices that correctly implement Rule 5.5. So it would probably cause some weird behaviors on like devices that are running old or like, you know, crappy software. But it wouldn't stop you from surfing the web. So yeah, I don't know how big a deal that is, but basically we can't specify what a poorly behaving stub router does, right? Like if a stub router is advertising a default route, it is violating the stub router spec. It's not supposed to do that.
Yep.
I mean, maybe we should be super clear about that, and I don't know if we've been. So yeah, I mean, I think we might want to, and this would be a new action item. We might want to talk about, so oops.
Esco, you want to go ahead and say something?
Yeah. The thought I was trying to finish here is just that we need in our specification for how we send router advertisements, we need to have a must not for default router, but I think we already do. Okay. So this is what we currently say. And we have an explicit exception. So I
Okay,
think
there
that's
are, good. Sorry, I'm interrupting in between. There are a couple of comments on chat also. Jonathan mentions that it's clear what a network without IPv6 means. Are we clear about that in the document?
so we're back to the
I just want to make a quick comment. Think of that for a second, Ted. If anyone has anything to say, please just unmute yourself and speak. We're in a small group here. We'll make this a little less formal, okay?
Yeah.
Checking the audio. Can you hear me now?
Yep. We can.
Oh, yes.
Oh, sorry. Yeah, I think my audio was not working. I tried a couple of times. I missed also the last minute of the meeting. Sorry. I think I had one comment about the thing with what Ted was mentioning about default route advertisement. So I think we had a PR some time ago that was merged that speaks about that basically advertising default route is not allowed by the stub router, and also adds, I think it added a case where there is a case where it is allowed to do it. So if the stub router is itself like a Wi-Fi router that has a cable modem uplink or something like that. So
that's this text here, right?
Well, I don't see the screen yet, sorry. But well, that's important. So I think we have something, and we could make a GitHub issue just to double check if it's clear enough for people that that this text is there. And the other aspect was we also want to talk about advertising default router on the Stub Network side. So I think that was also added in this PR, or at least I hope. So because there are cases where default route is advertised on the Stub Network. So that means that devices that are on the Stub Network see, hey, there's a default route and expect internet connectivity, and then we'll use the IP address to reach internet servers. And if there's no default route, then the devices won't do that. So that's also an important element, of course, of the router.
So is my screen being shared? Are you guys seeing this?
I can see it.
Yes.
Okay, so Esco, the paragraph here, this one where my cursor is the one that's talking about the router lifetime on the infrastructure side. And it does say exactly what you said. And then this is the section for the stub side. And what we say right now is if we have a default route, we're allowed to advertise it. Although there may be cases where we don't want to. So we're not required to. We do say this, now in the thread use case, specifically, we have two behavior patterns right now. One behavior pattern, this is because the thread network data is very constrained in size, and so we can't just have an arbitrary list of prefixes because prefixes are big. So what we do on the thread implementation of the stub router is if we have a default route on the infrastructure link, then we just advertise a default route on the stub network, and that's it. If we do not have a default route on the infrastructure link, the assumption is that we have ULA addressing on the infrastructure link. Either we're providing it or some other stub router is providing it, and therefore we advertise a route to the entire ULA prefix FD00::/8. And those are the only two things that we do. So this text should allow that behavior, and I think it does. Yeah.
Okay.
So I think okay. So we're good.
Yeah. So I think I'm not sure if we discussed about this, but I had one kind of major comment on the pull request text. That was basically that you could have a managed not home IPv6 network. So it's managed, it's not in the home, and it does not have RA guard. So I think that was one of the cases that was flagged as, hey, this is a bit of a worrying case. And of course, we can keep saying like that's not supposed to be like that, but I think formally you can make such a network, and that's why we also have to list it under the topologies appendix. So this is a case where the stub router will kind of mess up the configuration, especially if
except no, it won't. That's not true. Let's be clear about that. Okay. So we actually cover that in the appendix already. And I don't think it's true that we would mess up the configuration. What would happen would be that on such a network, if no usable prefix is being advertised, we would advertise one. And that would mean that some hosts on that network that perhaps are not permitted to get an IPv6 prefix delegation or an IPv6, like if they're doing DHCPv6 only, then the infrastructure is controlling whether they can get whether they can get an address from the DHCP server. And so now we're advertising a PIO option on that link, and it's autonomously configurable. And so hosts that aren't getting addresses from DHCP will now get an address from this new prefix. Also, hosts that are getting an address from DHCP will get an address on this new prefix. However, and though they might use that address for communication on the local link. So I guess the scenario where we would have the only time that I could see this being a problem is if like somehow they don't have RA guard configured, but they do have some other weird thing I've never heard of configured to block communication using source addresses on a certain prefix. I guess that's possible. Like if you've got, maybe you have the DHCP server configuring a table in the switch, but I don't know of anybody who's doing that. That seems like a very weird thing to do. It's very heavyweight.
Yeah. No, I was thinking.
And we're proposing both that RA guard is not present and that they're doing this super heavyweight thing with DHCP, and that just seems implausible to me. So
yeah, I was thinking about another case. So it's basically no RA guard.
Yeah.
And there is DHCP v6 for addresses, but there is no prefix delegation happening. So that basically means that the stub router can get its own address from the DHCP server, but it sees, hey, there is no usable prefix because there might be devices that don't support DHCP. So I will just announce my own ULA prefix here. I think that is kind of the example where, well, you could say messing up in the sense of now, besides the intended configuration, there's now also SNAC basically being enabled on that network, which is not something the operator wanted to do.
Right.
So that's I think the case. And
so the reason that I went a little farther with that, Esko, is because I think that there's a distinction to be made here. It's definitely not the operator's intention that there be a SNAC prefix on the link. And so in that sense, what you're saying is true, right? The operator's intention is being violated here. But the reality is that the operator has not actually expressed their intention by blocking that. And they have to express their intention by blocking that, or else it can happen. And it's not just a stub router. Anybody could advertise a PIO option on the link, and it would,
but it's just that I think the idea was that of course anybody can do it, but it should not be a product strictly according to an IETF specification. Should not do it. But
this is a thing that we need to be super careful about, because basically what you're saying creates a situation where we literally just can't do this, right? Because we don't have a way to detect that this is the situation. We have no idea what the operator's intention is. We can't there's no way that a silicon device is going to be able to telepathically guess that the operator doesn't want SNAC. So if the operator doesn't want SNAC, the operator has to be the one that takes that action. And so so I think that it's actually incorrect to say that, because think about this. Okay, another example of where this could happen is I'm an end user. I mean, think about the tethering case that I just brought up. We've got a device that's doing tethering. It's got IPv6. It's sending out an RA on the link to enable tethering on the link, and the operator didn't intend for that to work. And so now we have an IPv6 default route that's being advertised with SNAC, and all of the devices on the network can communicate using that default route over this poor bastard's iPhone, right? It's had no idea how much bandwidth was going to get consumed. But the point is that that's something that can happen. It's got nothing to do with the stub router spec, right? Where this is not a stub router. This is actually essentially an edge router that somebody connected to the network without permission, and the network operator didn't disable that, even though the network operator doesn't want that to happen. So I think we're not creating a new situation here. We're not creating a new problem here.
Right. So I think we should explain maybe why it's not a problem for that, even for that particular case. So I was thinking about maybe it's not intended to have SNAC there, but on the other hand, having the SNAC there if it doesn't hurt. Like suppose that a device that first had the DHCP address and was working fine, and now suddenly switches to a SNAC address and can't do its job anymore on that company network.
Right, but okay.
So could that happen? I don't know, but
no, I don't think that can happen.
Then we're fine, I think. But we just want to say that the device keeps working even in that case.
Yeah. So what could happen there is if we were advertising, so we're advertising a ULA.
Right.
And so that means the ULA is not going to be selected when we're trying to communicate with the GUA. It's only going to be selected when we're trying to communicate with another ULA. The scenario that is actually a potential risk is, suppose we've got a managed network that is advertising its own ULA address space. It's allocated a ULA prefix for site use. It's not doing prefix delegation. And now we look at the network and it's not doing prefix delegation. It is blocking autonomous configuration. So you're only going to get to use the ULA if you have permission from the DHCP server to use it. So now the stub router comes out of this network, sees that there isn't a usable prefix, and starts advertising a PIO that is autonomously configurable. So in that case, on this particular link, we now have two ULA prefixes that are going to be, and this is again based on the discussion that we've been having independently of this in 6man about new behavior for ULA prefixes. So this isn't even the current behavior for ULA prefixes. But in this situation, we have two ULA prefixes advertised on the link, one of which is advertised by the stub router and one of which is advertised by the infrastructure router. And there will be hosts on the link that might get an address on both prefixes. And then the question is, will that work correctly? So the thing is, in the current source and destination address selection specification, that device probably also has a GUA. And the current specification is going to select the GUA in preference to the ULA when communicating off network, I think. That's my understanding of the spec as it's written today. We're talking about updating the spec, but there will be two changes in that updated spec. One is we will require Rule 5.5, which we previously said was a may. Now it's going to be a must. So, and then we're going to make it so that any ULA that we see on link is going to be considered to be a local ULA, which we can now prefer over a GUA when we're communicating with another ULA. But Rule 5.5 is going to prevent us from using the wrong ULA in that case. So I think even in that case, this is assuming we've updated the specs to this new behavior that the specs don't currently provide. In that case, it's still going to work correctly because Rule 5.5 saves us. So I think we're okay there. And we could go through like a long dissertation about all of the stuff that I just said in this document, but I don't know if it's worth doing that because that's like a lot of detail and we're speculating about a 6man draft that I think has been adopted. Yeah, it's in last call, but there's a big discussion going on and the discussion is not finished yet. So
okay. Yeah, I wouldn't use that thing at least, but yeah, so maybe it's good to point out this very particular case. Let's say, so if the operator uses DHCP with its own ULA namespace and no RA guard, and yeah, it could be some particular cases where the existing nodes start using the wrong address, maybe.
Okay, so
I'm not sure.
So let me just write a sample paragraph and let's see if this addresses your concern.
We
so
can always update it later.
Yeah. Implement RA guard and does not advertise what this document considers to be an acceptable prefix and does provide So in this situation, it will be the case that two prefixes are being advertised as on link, and one is being advertised autonomous configuration. In this case, a host that is attempting using the site ULA prefix on a different link may choose a ULA address as a source if it were to choose the autonomous So the bad behavior here, I mean, as I type this out, I'm realizing that there is something different that would happen here. We would see some effect of this, which is that that we might see some unexpected traffic from weird IP addresses. So I guess the question is, like, my opinion about this is that, so first of all, there's not going to be a change in in the experienced behavior for the end user, because this is a host that was not able to communicate anyway, okay, because it didn't get a prefix from DHCP. So this host isn't able to communicate with devices off network anyway. It's only going to be able to communicate with devices on the stub network, first of all. Secondly, if the router is configured correctly, it's going to actually block transmission of this ULA sourced address. That's to say, the infrastructure router. It's going to block that because that address is not an address that it's advertising. So I think I don't know. It's possible that it wouldn't block it, but the worst case scenario is that some host on another network is going to get some bogon packets that it doesn't know what to do with. And then if the operator sees that, basically the operator is only going to notice that if it causes an operational problem, right? So if the operator notices that it's causing an operational problem, they have a couple of options. They can filter on the router, or that is to say, they can filter based on the source address at the router, or they can enable RA guard, which they probably should have done in the first place if they really cared about this. So I think that covers your scenario, and I think the answer is it doesn't actually cause an operational problem.
I'll be careful about using block by the operator term because generally we are dealing with home network, which is still a
No, no,
non-expert domain.
no. This is specifically for managed networks. Look at the subject line up here, right?
Okay.
Yeah, so we're okay in that case. There is an operator here, thankfully, or perhaps not thankfully, since the operator is being a bit of a control freak, but that's all right. So this can be blocked by the operator. I mean, there's a lot of detail here. So
So is this one of the cases of not properly managed networks then?
well, I don't know if I would describe this as not properly managed. I would just say that this is a network where the operator does not care sufficiently about blocking,
Okay.
maybe the operator just doesn't really care. I mean, they might have enabled DHCPv6 because like that's the default configuration that their device came with. And,
Okay.
so we don't really, we have no way to know what the operator's intention was here.
Yeah, we should avoid things like properly managed or correctly, whatever.
Yeah.
Because someone's going to always have a case where they're properly managing or correctly doing something, but it's different than what we've assumed.
Or they want us to define properly managed, which then is a rabbit hole of rabbit holes, right?
Exactly.
Yeah.
That's even worse, Tim. You're right.
Yeah. Oh, yeah.
So I think that's all we really need to say. That was a lot, but I think we now have a pretty clear document for, we've clearly documented what the issue is here. I guess I could make this a subsection. Okay, so I think that covers that. Esko, are you okay with this?
Excuse me.
In the first paragraph, just it will be the case that two ULA prefixes, to explicitly say ULA.
Actually, I think it would be more correct to say it could be, because it's also possible that we're only advertising a GOA prefix on that. That is to say that the infrastructure only advertises a GOA prefix, in which case this is just a non-issue.
Yeah, then I guess the start of second paragraph, in the case that, well, sorry, we should say in the case that it's 2 ULA prefixes. Yeah, sorry, not that easy.
Well, I mean, so this actually makes it pretty clear, right?
Okay.
It's communicating with a device that's using a site ULA prefix. So it could choose a ULA as a source address.
Okay, that makes sense.
Yeah. So actually, if there's only a GUA advertised on the infrastructure link, it's good that you brought this up, Jonathan, because I hadn't thought about this case. So if there's only a GUA, then closest match could result in us choosing the ULA prefix that was advertised, and then that would prevent communication. However, if the host that's trying to communicate off link is following Rule 5.5, that wouldn't happen. So yeah.
Isn't there also a case of longest prefix match? So if the destination is the network's own ULA, then the source will also be the
Right.
network's own ULA instead of the
Oh, yeah.
SNAC ULA.
So no, the scenario where this would fail is where there is a site ULA, right? But it's not advertised on the particular link that we're on. So we're trying to communicate with a device that has a site ULA address, but all we have is a GUA source address or the ULA address that was provided by the stub router. And in that case, we could actually see a failure to communicate using that source and destination address pair. If the host is using happy eyeballs, it's still going to try the other address and that'll work. But now we actually do have a scenario where, and this is a weird scenario, right? It's just like we've got a site ULA, but we're not using it on the local link. That's the only time that we can get a failure. So.
Okay, I'll check this later. Again, I'm still not seeing the screen share, so a bit hard.
Oh no. Are you able to see anything?
Well, I see boxes for the speakers and the chat works, and the audio works, and it says a screen share is being started.
Okay, I wonder if you've got if you have what is it? WebRTC disabled somehow on your system, because it sounds like you're just not getting any video streams.
Also,
Yeah,
yep. Go ahead.
Oh yeah, it did work before. Yeah, no video at the moment. That's right, but it did work before.
Maybe try doing a reload.
Yeah, I did.
Oh, okay.
Didn't work. But anyway.
Yeah.
Yeah, I can check it later when it's merged. Also, see if there's anything to be added.
I was thinking, Ted, generate a text version, like
yeah, I'll do that in a second. Yeah.
You know, and stick it in the repo. I was gonna go and build all that stuff, and I was like being cranky. So,
Okay, so that's a definite failure scenario. I don't actually have a suggestion for how to prevent it. Okay, so I'm gonna save this and push it. Okay, so Esco, if you do a git pull, you should see the new text now.
Okay.
All right, so should we move on to the next section for now? Esco, you can always, yeah.
Is longest match is a better term or longest prefix match? What were you meaning to say? In
I
this
meant
case,
the longest prefix mash, yeah. So
we can correct here. I just wanted to clarify.
yeah, I don't actually know what. Hang on a second. Longest matching prefix is what they use, so let's use that. Yep. Okay. So we got that. Thanks. Okay. So then for managed network without IPv6, we just say that since there's no service, we can't really cause a new problem other than just that something could be reachable that wasn't expected to be reachable. Maybe we should, rather than saying properly behaved, we should say stub router that conforms to this specification will not advertise a default route. Therefore, it should not cause operational problems. And then an unmanaged sorry, did you have something, Karen?
No, I'm just confused about why would we mention non-home in the bracket?
Right. So we already covered an unmanaged home network. So an unmanaged IPv6 network that does not implement RA guard. So what is the distinction here? What do we mean by non-managed home?
Non-home only gives me an indication that again there is an operator involved.
Well, I mean, so an unmanaged non-home IPv6 network would just be an IPv6 network where the owner of the space has purchased has purchased an internet connection, and they have an edge router configured. So it's basically the same scenario as a home network, except that maybe they're doing things a little bit differently. So let me just describe the scenario that I'm thinking of here.
Yeah, I think one of the surprising things about the text was that it's called unmanaged, but there was still somebody called the operator. So we had some back and forth about that.
Yeah, maybe owner might be a good.
Yeah.
Yeah.
So the operator could be just the person that gets the box by mail and then sticks it in the wall or something, and doesn't change any configuration and doesn't know about any. So that seems okay. So I think the intention was to have like a small business network. It looks almost like a home, except it's not a home, but a business.
Yeah. So what I'm saying right now is in this scenario, you have a site that is not a home, so perhaps a restaurant or business where there is no network operator per se, and the network is deployed similarly to a home network.
Yeah.
Per se, but the last paragraph is something to address the case where the operator is not knowledgeable. Okay.
Yeah, as I type this, I'm just feeling very unclear on whether we actually need to make this distinction. I think actually what I would say here is that there's little difference between these two scenarios.
Yeah, you can refer back to the home section maybe.
Or is it possible that whatever is the difference we can absorb in the home case itself, so that we are not like there are not too many subsections or different scenarios to handle, and can
Yeah.
somehow we can collapse with the home section itself.
Well, so
I mean, we can do that later offline because that would require a little bit of more thinking.
yeah, I mean, I just yeah, this is sort of supposing that there's an operator when the network is unmanaged, which I think is wrong. I think what's potentially interesting about this scenario, so one thing to say about this is that a stub router doesn't really create any significant difference as compared to just connecting a device to the Wi-Fi. So like suppose you're walking into Starbucks and you brought with you an IoT light bulb that somehow you're powering and you somehow connect it to Starbucks network, right? I mean, this is a very contrived example, but you've got this device, you connect it to Starbucks network, um, and uh, and it starts advertising the light bulb service, right, using MDNS, and maybe it tries to connect to some cloud controller or something, like, who knows. But anyway, the point is it's just behaving like a regular device. Now, if that device were connected directly to Wi-Fi, the behavior that the operator of the network would see would be essentially identical to if it were connected to a stub router that was connected to the Wi-Fi. We'd see a service advertisement. Devices on the network would in principle be able to communicate with it or control it. Nothing really different would be going on there. And so I don't really think that there's an interesting problem here. I think it's worth talking about this as a separate scenario, but I think that the answer should be that we just point back to the home network and say, because the one difference here is that in a home network, you can have a guest network and a sort of non-guest network, and you give guests your guest network password, and the guest network is isolated from your home network. So guests don't actually have the ability to communicate or discover or communicate with devices on your home network.
Same
So
is true for Starbucks too, though. You've got the user, like the guest,
right, yeah, that was what I was getting to. Yeah,
customer
exactly.
network. Okay.
Yeah. So you go into Starbucks and you're essentially in an isolated network mode. And in fact, like I have OpenWRT running on the router that I'm using for our conversation right now. And there's a checkbox you can click that says isolate hosts. And it basically says any host that's connected to this network can only use the network for internet access. It can't use it to communicate with other hosts on the network. You can do that on the guest network, and you can also just do that on the main network. So I think that's the same scenario here. And we don't need to do anything special about it. It's just, I mean, I think we should maybe talk about that, the guest network scenario. And I don't think we do currently. No. So I'm going to just add a note here. To talk about the guest network scenario for unmanaged home network. And then I think we could just have the unmanaged non-home network talk about what that would be and why it's basically the same use case as the home network.
So it
'Cause I
sounds
think
like
it
your
is.
a section that is unmanaged network with a subsection that says unmanaged home, unmanaged
There you
non-home
go.
network.
Yep.
And say an unmanaged network, here's what happens, and these other two are exactly the same.
Yep. That makes sense.
But you know, may have different considerations, but they operate the same way.
I think all of this text about RA guard doesn't really make sense. Yeah. So, all right. So I think that what we now have here probably covers this adequately. With, you know, we'll talk about the guest network scenario. I'm not going to type in that text now because I think, you know, we spent a long time on this topic. The question is, so we've covered the unmanaged home / office / business network scenario. We've covered the managed network scenario. We've covered the specific managed network where DHCP-v6 is required, but RA-guard is not present scenario. And we've covered the managed network without IPv6 scenario. Are we missing any scenarios?
So without IPv6 is same as NAT scenario, right? NAT 6, IPv4 NAT. Yeah. So we are okay.
Yeah, well, so from the perspective of a stub router, a SNAC stub router, an IPv6 network, a managed network without IPv6 is essentially just a link with no IP addresses on it, right? Because stub routers, I mean, I suppose the difference is we do get an IPv4 address, so, or we might get an IPv4 address. So the only thing that's so in this scenario, there's two things that can happen. One is hosts on the stub network can communicate with the internet using NAT64, right? That's just one of the functions that stub networks provide. And so there we are. And then the second thing is that we provide the ability for hosts that are on this managed v4 only network to communicate using IPv6 only with stub network devices. So the thing that would be weird to the network operator would be that suddenly there would be IPv6 on their network where previously there hadn't been. Now I will say, you know, we've been shipping devices that do this for like 4 years now. And we occasionally get like somebody sending us a question of like, this is a little weird what's going on here, but we've never actually had someone come to us and say, this is a serious problem we need you to fix. So that's kind of my observation about this situation. Like, it's not going to cause a problem. The network operator might notice it. If they do notice it and they think it's a problem, they'll probably just turn on RA guard. Or they might notice it and not think it's a problem.
Okay, so I think then we are good. We have covered scenarios. Should we keep this issue open for now till we do the final polishing, or we can close to this day and
Well, so let me finish the text about the guest network scenario, push this, I think unless there are objections to this as it stands, and I'm assuming that the guest network scenario is probably not going to create objections, but if it does, we can open a new issue on that. So what I would say is let's have this pull request close the issue that's associated with it. And I'll try and do that when we're done here. Does that sound all right?
Good for me.
Yes.
Okay, great. Then the next question is, so that's this pull request. Now we've also got 13 issues open. The RA flag bit position thing is we already dealt with.
I issued another pull request for one of the older issues.
Okay.
A few minutes ago, if you go to that, Ted.
Which one is it?
In the pull request, just scroll up.
Sure.
Pull requests. Yeah.
ULA advertising.
This is maybe an easy one to knock off. There was some as needed text. I think the as needed is now state beacon advertising.
Okay. This looks good to me.
Okay.
Yeah, if you want to just commit that and just
Good.
merge that and if you add closes issue number in the document, it just closes number 55.
Did that. Good.
Or resolves maybe.
Yeah. Fixes 33 it was. Yeah.
There we are. Yep.
Good. Do that.
Okay, so we've covered that, clarify text as needed. We've covered RA flag bit. We've covered taxonomy. Relax requirement L bit is set.
Yeah, actually, I remember writing text for that, maybe even merging it. I haven't checked it up front of this meeting if that's really the case. So what I think I added was basically some text saying that for specific link types where the L bit is not supposed to be set, then it's okay to not set the L bit. I think referring to another specification.
Yeah, so right. So a prefix is not considered if the L bit is set, but the A bit is not set. That's not your point.
Yeah, I think if L equals 0, basically, doesn't make a statement about on link or off link. So it's kind of unknown. And some link technologies always use L bit 0, I think.
Okay, but if the L bit is 0 and the A bit is set, what does that mean to do? Do we do slack in that case?
I think you can still do Slack in that case. Yeah.
Slack, but all the packets are routed to the router.
Yeah.
You don't do on-link termination.
Gotcha.
I don't have practical examples, but it's possible to create a link technology that has that property, so that all the packets have to go to the router.
Yeah, one of the old examples was for mobile IPv6.
Okay.
Right. Yeah.
Right.
So there's a little bit. So let's see. So how do we do duplicate address detection in this scenario? Because we can't do neighbor solicitations and advertisements because we're going through the router. This sounds like maybe in principle it works, but in practice it doesn't.
Okay, I see now the text I referred to was already integrated into the specification.
Oh, it is?
It's not for this issue. It was basically it's causing this issue. That text. So the text says you're allowed to clear the L bit if the technology requires it, and now that causes the issue that is mentioned here. Yeah.
Yeah, so I think that there isn't a use case where you could connect the stub network to the infrastructure network and not set the L bit. That is, if you're connecting to, well, so I guess maybe a different way to say it is, in that scenario, the only way this is going to work is if we use prefix delegation. Because we can't do SLAC, because at least I just don't see how this is going to work. Like I just read the SLAC RFC, and it doesn't say how to handle this case. So it may be that some other RFC says, yeah, sure, you can not set the L bit and still do SLAC, but does it say how? Do we have an example of an RFC that says how?
I don't know.
So that would be my question. I think this is out of scope. I think like us trying to address this question is pointless. I'm willing to be argued with on this. I'm not asserting this definitively. I'm just saying, please come up with an example where it would make sense to do this, and we can work from that. If we don't have an example where it makes sense, I don't think that it makes sense for us to try and say anything about it. Does that sound okay?
Well, then we, I think, have to be clear that SNAC stub router is only considering the case where L bit is set, can be set by the technology.
Yeah, so right. So actually, that's a good point. What we should say is there may be scenarios where a stub router, or sorry, where a link, where it doesn't make sense to set the L bit for a link, but it does make sense to set the A bit for the link. This document does not cover such use cases. Does that sound okay?
Yeah, maybe something like that would be good.
So then, do we have an applicability statement yet?
So I did not understand it. That means L bit should always be set for us for the stub router.
Right. So here's the problem. We're making a stub router, and we want to be able to connect it to some kind of link. And if the stub router is connecting to Wi-Fi or Ethernet, then that behavior is already understood and defined, right? Well, those links support setting the L bit and the A bit, so we can do SLAC on those kinds of links. And so we don't need anything new. We don't need to talk about anything new for that particular case. But there may be some other link type, some other layer 2 type. I think it's a layer 2 issue, right? There's some other layer 2 type where we can't do neighbor discovery, basically. That would be the case where we can't really set the L bit, because the L bit is essentially saying we can do neighbor discovery and communicate on the link that way. So on a link like that, we're going to have to send all of our packets to the router and have it figure out how to get them to the next hop. And, in a sense, you could say that like the thread mesh is actually an example of this, except that the thread mesh doesn't use RA at all. So it's totally, it's just, we don't really talk about that. But there could be some other infrastructure where we don't set the L bit, but we do set the A bit. And that would be a different layer 2 type. And so we don't know how to specify what the stub router's behavior should be if it's connecting to a layer 2 that does not support setting the L bit. I think that's really all we can say.
But that does not sound right. Your last statement that we don't know how to specify the behavior of stub router in that case, that statement itself does not sound right because we are providing the specification for stub router. We could say something
What
like this is not handled.
what I mean is that we literally don't know how to specify what the stub router should do in that case, and therefore that is out of scope for this document. Right. So we're saying like basically we're defining a stub router that works for layer twos, for infrastructure layer twos, where we can set the L bit. We might need to do another stub router document that talks about what to do for infrastructures where we can't set the L bit. But right now we don't know of any such infrastructures, and therefore it would be pure speculation to say how to handle that case. So therefore that case is just out of scope right now. Now, if we know about
Okay.
a case, then we
Okay,
should
so we can
document it.
write one sentence which says for infrastructure where we cannot set L bit, those cases are out of the scope. That's all
Yeah.
we need to say, nothing on that. Okay.
Yeah, I think that's right. So let's see. Well, all right. So I guess I can just add that. Let's see. So this is what I've written. There can be layer 2 networks where neighbor discovery is not supported, and therefore we cannot set the L bit, but could set the A bit. The behavior of stub networks when connecting to such networks is out of scope for this document.
Works for me.
Okay.
Yeah, that's great.
All right. So that means that we're actually going to. So this is. I still have this. This is on the. So this is number 51. But I'm on the branch for this pull request. So let's see.
Yeah, you can also solve multiple issues maybe with one.
Yeah. Right.
Yeah.
Exactly.
Should be okay.
Yeah. And so this fixes number 51 and number 56. I'm just adding this as a comment because I think it'll capture that when we merge this. Okay, and then there was actually an additional change in this pull request. So the maximum time period after receiving an RA that a stub router can copy flag is. This looks like it was just a space change. That's okay. We added that. Okay. Yeah, so it looks like the other stuff that's in here is just space changes, as far as I can tell. Yep. Okay, so this just fixes those two issues and no others. All right, so going back to the issues list. Now, one thing that I don't see here We had talked about changing the name of stub router to SNAC router, I think. Is that right?
Yeah.
Yeah, I think that's right.
Yeah, so we should probably add an issue here.
Have you already released, have you already committed to data tracker changes where we change from usable to suitable?
I believe those are in. Let me just check.
So I was wondering that these type of changes, should we make a separate commit into data tracker for them, just for the sake of clarification?
I don't think that's necessary.
Yeah, so suitable was now used, right? The new term.
Yeah, the suitable change was in the update that we did for the for the previous IETF. So that's already been committed. So we do have 2 fixes in this pull request. I'm not proposing that we add any more. I had that switch in, so, or sorry, that change in. So. Okay, so going back to the issues list.
I stuck in another pull request for an easy one, terminology cluster.
Excellent. Oh, did I? Shoot. Did I? I think I added this to the wrong.
That's okay.
Hang on a sec. I'm going to cut this out. Delete.
Sounds good.
Okay. And then go back to this.
Yeah,
that makes more sense.
there's one problem with the PRs that at least I'm not able to edit much about it. So like adding adding reviewers, adding assignees, deleting things, adding labels, so all of that is blocked. Is there something we can do about that to enable?
Oh yeah, get yourself added to the org, I believe.
Okay.
Yeah.
ITF SNAC working group, right?
Yeah, working group SNAC. One of the chairs can make that magic happen.
Yeah, I think I can add you here, Esco.
Okay.
All right.
That would be great.
Yeah, can you just drop me your user your Git user name in the chat?
Okay.
That's an interesting thing to say. I guess we don't really talk about nodes that only implement IPv4, so that's probably okay. Yep. Yep, that looks fine. So if you want to merge that would be good.
Okay, good.
So what happens when you have a host that is IPv4? It's part of like my home network, but not Stub Network.
So we just haven't really talked about that. And so, one thing to say about that, I don't know if we cover that. So let's see, must be capable.
Why is this not?
Yeah, we don't actually talk about that, and maybe that's a good point. So the one of the limitations of the stub router, the SNAC router, is that if you have a host that is genuinely v4 only, meaning it can't even do Slack, it's not going to be able to communicate with nodes on the stub network. It's not going to be able to establish communication with nodes on the stub network. It can respond when they establish communication. Does that make sense?
Can respond. And when they make communication, it's through NAT?
Yeah, the only
Like,
way that we're going to be able to talk to an IPv4 host is through NAT64, and that's only connecting out. That's not connecting in.
okay.
And that also counts for MAP-T devices,
Uh,
the dual stack world.
well, no, if the device is dual stack, we're going to be able to
Yeah.
communicate with it because it's got an
That's true.
IPv6 address.
Yeah,
Yeah.
you're right. You're right.
So the reason I raised this was because in terminology we said that node is IPv6 and host is any node that is not a router, but host can have IPv6 addresses. So we need to loosen that definition a bit.
Well, I don't think we do. I think a host that can't do IPv6 is actually not, like, we can talk about that without, I mean, I guess, we could change the definition of host to be a host that can communicate using IPv4 or IPv6, but most of the time when we say host, we actually mean a host that can communicate with IPv6. So I think it makes more sense to just document the exception that if you're trying to, if an IPv4 only host, or a device that does not, we could just use a different term. We could just say a device that does not implement IPv6 needs to communicate. A device that does not implement IPv6 will be unable to establish communication with a host or with an with a. Yeah.
So yeah, we just defined host as an IPv6 only thing.
Mm-hmm.
Okay.
Well, yeah, I guess sort of.
All right.
We are 10 minutes away from our stop time. Is it a good logical point or something we can quickly wrap up in next 4 or 5 minutes?
I would be happy to stop now. I need a bio break, and we've done a lot.
Yeah, you've done a lot, Ted.
Yeah.
Yeah.
Yeah, if I want to make a suggestion too, if anyone else on this call or anyone on the mailing list too wants to start fixing issues and submitting pull requests, I'd make a request to add yourself or send me your Git user ID and I'll add you as a contributor.
So the plan is to meet in 2 weeks again?
Yes.
Yep.
All right,
I thought I
thank
had
you. So
scheduled that, but it might not be. Just as a housekeeping item, I think my batch attempt to schedule these failed.
Oh, whoops. Well, you have 2 weeks, so I guess
Yeah,
no,
exactly.
it's probably 3 weeks then.
Yeah, no, it's the 2 weeks. It's actually a 2 week. It's a 2 week minimum, is what it is.
Yeah.
On what it's
Right.
suggested.
So
I'll do that now, and we'll see if it succeeds.
Okay.
Okay, thank you guys.
Yep. Thank you.
Yep.
Thank you, Ted.
Yep.
Thank you.
See you guys later.
Yeah, great job.
Bye bye.
See you later.
Bye.